Yeah, let's get started. So today we'll be talking about decentralized applications, dApps, 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 dApps. I hope you guys can see me clearly. Um, if you guys can
Yes, we
indicate,
can.
please.
Yeah,
I think okay, cool,
we
cool,
can.
cool. Let me share my screen as well. Um, so today we're talking about decentralized applications. So while I'm setting up my screen, can we all kind of indicate like what we understand by decentralized applications on the chat before I share my screen real quickly? Yeah. So by the way, it's already been 4 weeks. Yo, it's been a long session, and I really hope all the classes have been very useful for everybody. Our goal is to help us become actual developers, Web3 developers. So yeah, I hope it's been useful. We'll ask for your feedback at the end of the bootcamp, anyways. But for now, um, yeah, for now, this is where we are at. So I hope we can see my screen clearly.
Absolutely.
Perfect, 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 perfect. Okay. So I'll just start with that. So decentralized applications. So I don't know if anyone can type on the question what we understand by decentralized apps. Um, but basically, I would explain what I understand by this decentralized applications. So decentralized applications are basically web applications, digital applications that are run using data and interaction from blockchain, a blockchain network. It could be any network. It could be Ethereum, it could be Binance, it could be Cardano, etc. Right? If your application is running based on data, because we all know, I assume most of us application developers here, applications generally are web applications. Basically, are web platforms that use data to interact with the user, right? So, for example, if we have our Facebook, it's a centralized application that uses all our data to kind of create like interactions that serve a purpose. A friend can post a Facebook picture, the data is hosted somewhere on the cloud, and everyone clicks on it, like. They say, oh, this is a nice picture. It's interaction. It serves that purpose of interaction, right? So decentralized applications basically are applications that are hosted somewhere, but the data that is serving the user, so the data that is being seen and is being used, if you want to store a to-do application, for example, you can create a to-do application, launches a smart contract, and the data that is being read from that smart contract, if it's being loaded on any interface, and the interface is being read by a user, that application is a dApp, is a decentralized application. So basically, an application that connects to a peer-to-peer blockchain data source and uses that data for anything useful, right? Application that works on peer-to-peer. Thank you, Samuel. Yeah. So yeah, exactly. So I feel like we all have that definition down. So let me so I've talked about centralized applications, for example, Facebook, for example, Evernote, if people take notes and all these things. All these applications are centralized because they are hosted in a centralized way, and all the data are hosted from a centralized source. Decentralized applications, or dApps, are hosted, data are from a decentralized source. So usually the way we interact with data hosted on a blockchain are usually from the typical website. So, for example, a website you can launch the way you would launch like a Facebook app or a centralized app, where you put the web, do the JavaScript, you host it somewhere, and it calls the database. It's the same way you would do a decentralized app. You would do the JavaScript application, launch it somewhere. But instead of telling it to call some Microsoft SQL, or call some Postgres, or call some MongoDB. You tell it, okay, make interactions with the blockchain and call the blockchain data. So that's basically what dApps are in a nutshell. So what are popular use cases for decentralized applications? So this decentralized applications are used for a lot of use cases. So there is GameFi. So gamers who might know, it might be a popular term, play to earn, play to whatever. Um, so basically, GameFi is their gaming applications where the data is stored on the blockchain. So applications like Axie Infinity or the rest, you can play, you can go buy a like for example, you say, oh, this sword of infinity will help you kill this bad guy boss, right? You can go buy it in an NFT marketplace, and it will connect because it has your blockchain address. That blockchain address, that your wallet connects to the game online, and then the game sees your wallet and says, oh, you have this Axie Infinity sword, and then it reads in the game like you own that sword of infinity, and then as you're playing the game, you get that sword and you kill the bad guy. That's GameFi. DeFi, basically, they are decentralized exchanges. So decentralized exchanges are like, um, basically you used to buy and sell, um, um, you used to buy and sell currencies. So it's centralized exchanges generally are like forex or stock exchanges. The popular one, I want to use one that's more African. I know Nigeria, they have Rise, or other exchanges where you can see, okay, this is the stock market, this is it, or this is the forex. We can go and buy and sell. All the data are centrally hosted somewhere, and you can interact with it. But DeFi is like, obviously you are interacting. For example, most of these decentralized exchanges, they have data from different um, blockchains. So if you can go to Aave now and say, oh, I want to sell my USD and buy Binance, so that I can go on Binance platform and buy something and the rest. So all the data that is being used, and that you read from, and um, that the application uses to make those trades and those exchanges, they're hosted on a decentralized network. So that's DeFi. So entertainment, there's stuff like Audios. Audios is, I mean, it's not as cool as Spotify, but it's supposed to be like the Spotify or the iTunes of decentralized networks. So when you create a music NFT and stuff, an application like that, you can listen to it and you can play it. I mean, I feel like it has, like, it's not as popular, but yeah, you guys get the picture. Sandbox is a VR room. So all these platforms, I encourage you guys to just, if you need the links, I can send them, but you can just Google it and you'll see it and you can play around with it. And then governance use cases. So I'm sure maybe we have not spoken in details about governance, but most blockchains are basically they're virtual machines, right? Like the Ethereum and other blockchains. Everything is decentralized, and people are mining, people are staking. So a lot of communication is being done to make the blockchain work effectively, right? So, but when we want to decide, okay, what how are we what decisions do we make on this blockchain? How do we introduce an update? How do we make changes? A lot of times these are governance decisions on that chain or on that protocol, depending on so like Ethereum now is a chain, but inside Ethereum there are stuff like Pi DAO or different tokens, right? That if you want to make a decision around that token, you are doing it on Ethereum, but it's also centralized around that token. So there are some applications that will help you maybe cast a vote for Ethereum to, for example, the merge. Now, a lot of us must have heard about the merge. It's basically Ethereum kind of updating their software and making a lot of changes that will change the entire protocol. This merge has been proposed for years, and a lot of people voted, right? Using their Ethereum, using staking, because okay, if you have an Ethereum, if you have like maybe, I'm not sure the minimum to stake to vote then, But if you have Ethereum, you can stake it and vote and say, okay, I vote for this merge to happen. I vote for this merge not to happen because it will not be good or whatever. So yeah, so these things happen for Ethereum and for other tokens. So applications that you do this on are like websites. You can go to the site, click on votes, and it goes to the blockchain and does those interactions, right? I don't want to get into every single detail, but it will be good. It's always good for us to have like a general understanding of everything. So, what is a typical application for a decentralized system, right? So the typical application is there is a browser. You guys can see from the browser. There's a browser where you have your wallet, which usually you need a wallet connector. So you need a way for your browser to know who is trying to interact with blockchain. So the wallet connector now has different chains that you can connect and the rest. I'm sure Ebuka and everybody has walked through MetaMask with you guys. I'm not gonna go into details with that, but that's your connector, right? And then you need it. Most connectors, they have browser plugins, so you just install it in your Chrome browser or in any browser that you use. And so those things, when a user comes into the browser, connects their wallet, they now communicate to the web page, and the web page has plugins such as Web3.js or other kinds of plugins, right? That helps the JavaScript code know, okay, this is the wallet address that's sending this request. And they use that wallet address, and then they create a block. They sign that block with the logic of the JavaScript. They say, okay, this person wants to do this. So as a JavaScript person, maybe I might add my commission. Maybe I'm the coder. Maybe I want the website to get to 0.5% of every transaction. So if the person sends something, I add my this thing, or do you get, or however we want the interaction to be, we now create that block and we send it to the blockchain. So that's a typical, very simple architecture of how a decentralized application would work, right? Let me pause as I'm talking. If there are questions, the slide will be shared, please. Yes, Gibson. The slide. Thank you. The font, right? I know it was nice. Not my font. It's a Keynote font. It's cool. So back to the messages. Back to the slide. So I've already kind of verbally talked about how it works. There is usually a user interface where it's hosted somewhere. Either has JavaScript, React.js. I said React.js, Angular, something, and then there is usually a blockchain connector. So it's either MetaMask plugin or Trust Wallet plugin or Wallet Connect plugin. There are so many different plugins for different networks and the rest. And then the back Ethereum node will get to the blockchain. So there are different types of decentralized applications. So I put everything here but basically they are fully decentralized and partially decentralized applications, right? Also there are centralized applications like Facebook, Netflix, and the rest that use basically just this centralized application and that's it, right? But for a fully decentralized application would use please this is distracting me a bit. Can you can I pause for like a second while I
Yeah, guys. So okay,
Hi,
she's
Ron.
back.
Sorry,
Thank you.
I'm back.
Welcome back. Yeah.
Sorry for the break transmission there. Yeah, you can use Python. So for any programming language, right? Because Python is a backend programming language. Basically, it's for backend scripting. So you can use JavaScript and everything to get who is making the request, how everything is being made, and you pass the request backend, and then your Python backend connects to the blockchain network and passes the data to the blockchain network. If it receives the data, it does whatever, either passes it back or does whatever with that data. So yes, you can use Python, you can use Golang, you can use PHP, you can use anything for your backend. There are a lot of libraries that help the backend to connect to the blockchain. So you are good on every front. Um, Back here, so there are different types of decentralized applications. So there are applications that are fully decentralized. An application that is fully decentralized is basically an application where all the data that is being used in the interaction of the application are all hosted on the blockchain. So when you make a call, when you click anything on that thing as fetching data, it's basically doing that data and sending it back. It is not relaying any data with it is not getting the data, hosting it somewhere and giving it back. No, it's getting it from the blockchain and bringing it back. So all the data on that web screen is live as it's on the blockchain. So there are a lot of applications like that connectly. For example, there is Ethersec is a decentralized exchange that connects directly. Everything there's no other means, there is no other data storage or anything. It just connects directly to the blockchain. CryptoKitties basically it's an NFT platform where when you connect, you go straight to the CryptoKitties smart contract that has been hosted. So anything that you click on the website just basically calls a function on the smart contract that maybe loads all the CryptoKitties, maybe CryptoKitties by so and so categories or so and so. They're all blockchain. It's all hosted on the blockchain, right? So a fun fact to tell you is most. I won't say. I'm not going to in percentage now because, to be fair, I don't have all the figures, but I would say a higher percentage of applications are partly decentralized and not fully decentralized. Partly decentralized applications are applications basically that communicate with the blockchain but save data somewhere, for easy user interaction or user experience. So if you see fully decentralized applications, they are usually very small. They're usually targeted at a smart contract. Those things only related to that smart contract, and that's it, right? And usually these decentralized applications are not the most user interface friendly, unless you have to have some level of blockchain understanding to be able to, because there is not very intuitive. As we have learned, P2P networks are different from centralized networks. So for you to interact with it directly, it might not be as intuitive. Like if you don't really know anything about smart contracts and stuff, you can interact, but they're usually not as interactive, right? Partly decentralized applications are basically applications you can host the application somewhere. You can host the React somewhere. For example, like an EC2, you can host the React somewhere, and then you can also host, for example, some data in like an S3 bucket, but it um, also calls the blockchain data for the blockchain database for data. For example, very a lot of, I won't say all, but a lot of NFT NFT marketplaces are partly centralized, because when you mint an NFT, you are minting just that one image, and a lot of times the one that is being minted want to show you different images. They want to be able to search. They want you to be able to filter data. They want to be able to see who has bought this. They want you to be able to see, oh, who is bidding for this, who is not bidding for this. All that extra information and data for who is bidding, who is not bidding, when he's not doing that. All of them are usually stored somewhere in a kind of centralized storage, like MySQL, PostgreSQL, something like that. But the actual data, for example, if you want to mint something, if you want to buy something, the actual source of truth is the blockchain. But those other platforms help to store like auxiliary data, like things to augment the experience, to make it more user, to make it look more like the centralized applications and the Facebooks that we are used to, and the rest. Right? So generally, partly decentralized applications are very popular because they are more user experience friendly, and yeah, a lot of people will be using a partly decentralized app without knowing that they are connecting to the blockchain, unless they need to make it a transaction, or they maybe buy something or sell something, in which case the blockchain will ask you, where's your MetaMask? Yeah, we have to know who you are trying to initiate this on-chain transaction. So the same thing with decentralized exchanges too. So the standard exchange, even etherscan.io, where we go and see a list of all the Ethereum transactions and the rest. I'm sure we have gone through it, etherscan.io, to see live transactions. But it listens to the blockchain, but a lot of the data is hosted centrally somewhere. But obviously, it's like most smart contracts, they have event listeners that kind of synchronize the data so that it's as real time as possible. But for interactive purposes, there are a lot of things on the website that are hosted somewhere else too. Same as Bitfinex, same as I'm sure Binance Centralized Exchange, and a lot of those exchanges too. Most applications, most dApps are semi-decentralized, is the point. So yeah, just a diagram showing the interactions, right? This is a diagram showing the interactions. So the user basically interacts with the software. They usually get MetaMask or something to say who they are. They use those things. They interact with the dApps, these decentralized applications, which in turn interact with the backend that use public nodes to connect to itself, the Ethereum itself. Or there are some platforms where you don't really need any backend. For example, you want to just do a simple thing, you can just interact with your wallet identifier that knows who you are, and you can just call the backend directly, and you can just call the what do you call them, the node, the Ethereum node, or any blockchain node, right? So that's basically it. So yeah, so semi-decentralized architecture relies on blockchain data, right? The source of truth in semi-decentralized architecture is on the blockchain, but we need to have in mind that blockchain network is totally different from where you are hosting your MongoDB or MySQL data, right? It's totally different. So there needs to be a way for your data to be aware of what's happening on the blockchain, right? And there needs to be, so that when the front end reads that your data, it is not different from what's on the blockchain. Because technically, as we are aware, applications that you might not think of if you are used to this centralized way of writing applications, is a thing about dApps is, since the blockchain is the source of truth, right? You're writing a decentralized applications trying to encourage users to be like, okay, yeah, you might not know how to interact with the blockchain directly, come to my website, and then you can interact with my smart contract, right? However, technically, your smart contract is already hosted on Ethereum or Binance or any other chain. So if I know how to interact with the blockchain, I can go there directly to make that interaction. It will still work. It is still hosted there live. You cannot restrict me from connecting to it directly. Well, technically, because it is public, to be honest, so someone can connect to it directly or connect via your website. So the data on your front end would need a way to keep track of the source of truth if the back end is the source of truth, right? Which is where solidity events come in. I'm not sure if we treated events in detail, even though it's not in detail basically, but is basically a way for Ethereum to um, I don't know if we treated events. Um, and I'm not seeing any other questions. I don't know. Am I moving too fast? Am I moving too quickly? Please let me know if I'm moving too fast or if I've lost any of you on the wayside. That will not be good. Um, okay. So, but really, so far, have we? Am I carrying everyone along? I just feel like I left some people behind. Can I get like some messages on the chat to just be like, are we all along? Do we all know? Are we all in the same place that we're talking about? Francis, thank you, Ademo, thank you, Motseki. Sorry. Okay, cool. We're along. Okay. Because I always like questions. When I don't get questions, I'm like, oh, am I talking too fast? Okay, cool. We're all on the same page. Awesome. So, yeah. So a good way for our data to remain synchronized with the blockchain data, which is source of truth, which is the source of truth, is by consuming or listening to blockchain events. If when we looked at the smart contract anatomy, we saw that there were things called events that basically it's basically a way for blockchain for the blockchain to spew data. Let me not say spew data, output data out of the blockchain, post it somewhere, and say this is from my block. This is from the blockchain, and this is some kind of data, right? Because the blockchain is very data economical in nature. When you're writing code in the blockchain, when you're using the blockchain, you always try to use as small data as possible, because the more economical you are with your data passing, data processing, the more economical you are with your gas fees, to be honest. If you don't want a user to come before they do one thing, your system has asked them for gas fee of 5 eat. Nobody will use the application. It will be hosted somewhere. It will not be used. So yeah. So dApps are generally data economical, so that each transaction is take very small fees, right? So the smart contracts have a way of emitting events and outputting it somewhere. So you can set up your backend to listen to Ethereum network events and update your database. So obviously, the practical for that is it's not going to be covered in this session, but it's pretty straightforward. You would basically need like a public node, a public node that basically Ethereum nodes that are hosted in different um, Ethereum URLs, basically, that different miners or different um, um, Ethereum providers provide for you to connect to, and like have a direct connection from the backend to the blockchain directly, right? So yeah, so you can use those public nodes to listen to events on your smart contract when you set it up with your smart contract address. So anything that happens, even if the person connects to the contract directly or via the front end, it should emit events that update your DB. So it still remains a source of truth. You understand? So yeah, so those are small nuances that are common with decentralized applications that you may not necessarily find from centralized applications. A centralized application can say, oh, even though I consider it bad practice, oh, when you make the request in the front end, you can just listen. If it is successful, you update it from the front end to, it might not be the most good, the best architecture. It might not be the best architecture, but technically, if it's a small application and if you're doing simple things, it would work. But for a decentralized application, chances are it will not work because no matter how small it is, um, your database are two different data and they have to they have to have a way to interact. Else, your MySQL or your MongoDB would be off, which would affect the entire system, which would suck for you. So yeah, so this is basically the summary of what we're talking about today. Basically, today was just going to be an introduction class, basically, for us to know what dApps are, for us to know how the interactions work, and for us to know what do you call it, for us to know like perspectively to get like the definitions and to understand what happens when you're working with a decentralized application. So from our next class is going to be a fully practical class. So in fact, I feel like from now till the end of the bootcamp, which is next week, we'll be having hands-on practicals all through, where I recommend everyone come with their laptops. Everyone installs all the plugins from previously, and then everyone follows as we are doing the interaction in the class as well. So yeah, that's basically it. I'm not sure if we have questions. I feel like I've done the introduction. Don't enter too much into the practicals, which is starting tomorrow. So, anyone has questions? Anyone doesn't understand something? Everyone needs clarity. This will be a good time. Sorry, not tomorrow. Our next class is Wednesday. Thank you, Francis. Oh, don't be angry. The year is running so fast. I'm just speeding up the year. No, it's on Wednesday. So anyone has questions else, I can give some resources that we can start installing on our systems, that we can start setting up our systems for the what do you call it, for the practical tomorrow, for the practical on Wednesday. So let me just do a walkthrough of what the practical session is going to be. The practical session is basically going to be, you'll be interacting with the JavaScript interface, right? And you'll be interacting with a library, which will be making a call to a smart contract. We can either use the token smart contract that we developed by Ebuka, we can use another smart contract. There's so many that are hosted on a test on it should be hosted on a test net. And then basically we'll walk you through how to basically take user input or something and then use like a Web3.js library to sign a request and send it to the blockchain directly, right? And then when we now make that communication, we'll see how it works on Etherscan, and then we'll basically keep working towards it and build a decentralized application. That will be like the final practice for the session. Thank you, Queen. I will send you more resources. I like how no one is really asking questions. Though. It's either we've been doing such a good job or we've been doing a bad job.
Someone hands this up. Gibson.
Okay.
Yeah, Gibson. You can unmute yourself, please.
Gibson, you can mute
Can you
yourself.
hear me?
Yes.
You can hear me?
Yes.
Oh, okay. All right. Yeah, I remember sometime back. I mean, when I was studying my masters, I attended one of the, I mean, one of the, it was a seminar like where students were presenting their different projects. So that's the time when I came across that one particular student was working on break. You developed a system, yeah, blockchain and so on. So to me, uh, it was like great. I couldn't understand anything and so on. But later on, when I asked someone about the blockchain and so on, they was like, uh, it's a place where you keep your data. You don't have to. I mean, it's like it's stored across. You don't have to. You don't need to have a specific database where you have to keep your data. So now, in this case, we have talked about decentralized, then centralized. I mean, centralization, and semi-decentralization. I should say so. So now, if you have your own data, maybe you have your own database and so on. So you have developed a blockchain system and so on. So, okay, or maybe for instance, you have a decentralized system that you have developed, and yet you have uh, your own database where you're keeping all the data and so on. So now, what about the other machines if they don't have the database? For example, if it is MySQL or MongoDB, but I know MongoDB most of the time maybe it's online and so on. So if you have able to use your local environment, like keeping your data there, like centralized, why the system is decentralized? Now, if the
Okay.
other um, yeah, if the other users access your system, but if they don't have the platform such as the database on their computers, how are they going to get it?
Okay. So let me explain that what partially decentralized means, right? Um, a partially decentralized application basically is an application that enables you to interact with the blockchain. You are interacting with data hosted on a blockchain network, but you are using data derived from the data that is hosted maybe on your MySQL or something, right? That information usually is derived from the data on the blockchain. So, for example, now use a popular NFT marketplace, right? Like OpenSea, right? You can go there, you can like somebody's NFT, say, "Oh my God, I like it," and the owner of the NFT will say, "Oh yeah, this, I have like my NFT has 500 likes. I'm popular, right?" Those likes are not stored on the blockchain. Those likes are stored on the MySQL server somewhere that is using the address of the NFT to store those. So when the application is hosted, it goes to the database and says, "Oh, this the it goes to the NFT and it goes to the blockchain. Says, okay, these are all the NFTs on OpenSea." And when it gets all the NFTs, when you are now looking at the data of the NFTs, when you want to get the details of it, oh, is this NFT liked? Is it not like those auxiliary data? It now goes to the MySQL. So those things are additional information. The source of truth is the blockchain. So but those things are additional information for usability so that users can interact with it in a way they are more familiar with. Do you get? So when you're saying other nodes cannot see that blockchain. It is it's centrally hosted, so it is totally independent from the blockchain. It has nothing to do with the blockchain, or the only thing it has to do with the blockchain is that you are listening to the blockchain and you're updating the data so that more users coming to your websites can see live more recent data. Do you understand? So it's the MySQL data or the data from another database is not being hosted on the blockchain. It's totally different. Other nodes, other client nodes have no idea of what you are doing. A different smart contract might want to interact with your smart contract. They have no clue of how many likes. They just look at the NFT, they just buy the NFT, they just move on. but the auxiliary data are mainly for user interaction purposes, right? So it's mainly for the purpose of your front end application, so that when a user sees it, they can say, oh, this is a popular NFT because it has 5,000 likes, right? So I hope I answered that your question. Um, Basically by saying like they are very independent and they are not dependent on each other at all, right? So key dApp features. Um, Key dApp features basically are um, where did I get key dApp features? Yeah, so basically, key features of a dApp, you have to have a user interface, usually HTML or React or JavaScript or Angular or Vue or something that you use for your front end. So you have to have a blockchain connector. So for a user to interact with your website, when you build a dApp, they need something like MetaMask or Trust Wallet or some other plugin installed to their Chrome or Firefox browser that helps that when they are on your website and they want to initiate a transaction, that connector that connector they would have set it up already with their private key, right? So that the connector knows who is this on the blockchain, whose hash is this, whose private key is this, such that when they have set up that plugin, the plugin is on their browser, right? Anytime they come to your website and your website wants to make a blockchain transaction, the website, before it signs, it is best practice, before you sign any block, you have to say who is signing this. So the website will ask who is signing. So usually when you go on decentralized applications, you see if you have your MetaMask set up, you either see the MetaMask pop up and say, oh, sign this to confirm, or oh, pop up, oh, this transaction costs 0.003 gas fees. Confirm. And once you confirm it, to take money from your wallet, oh, once you confirm it, to take money from your wallet to buy the NFT or to initiate that transaction, right? So that's basically, so it needs a user interface, it needs a blockchain connector, and it needs a blockchain signing mechanism. So a signing mechanism is basically it uses, like if you see this diagram here, I put Web3.js. Web3.js is one of the very popular JavaScript plugins, right? That you can use to have all the helping functions that help you sign a request and send it to the blockchain network, right? So you can use Web3.js or Ethers.js. There are so many libraries, to be honest, but there are some that are popular, right? And then as a JavaScript person, when you want to send a transaction, you use the Web3.js plugin and you say, oh, send transaction to blah blah blah, right? There are ways to send it. I may try not to go into the practical because practical is tomorrow, but there are ways to sign it. Is next class, which is Wednesday, but there are ways to sign it, and then there are ways to send it, and then it gets sent using the library. The libraries or the JavaScript libraries like Ethers.js or Web3.js, they make it super easy. It's just you calling one or two functions, right, on the library, and you basically have the transaction signed and you have to send, right? So that's the very um, those are the key features. An additional feature that's from the front end side. An additional feature is the what do you call it? Is especially on the back end side. An additional feature is they are public nodes. So if your application is not just front end, but if you are trying to maintain a database that is different from the blockchain, you would need a backend to interact with your MySQL, to your MongoDB, to your etc. Right? That backend can be Python, can be whatever, right? And then that backend, you connect it to the Ethereum network via a public node, and then it can listen to events from your smart contract or from any smart contract, to be fair, because it's an open system. Once you have the address, you can plug in and listen to the events and record it on your database and use it for whatever you want to do. So one thing I wanted to talk about is the someone mentioned what is someone asked what are ABIs. So ABIs are basically like interfaces. So I'm sure you came across ABIs when you were working with Ableton to create your first Solidity smart contract, right? When you wrote the code in Solidity, it was looking nice and good on Remix IDE. When you say compile, it compiled to bytecode, which is launched on the blockchain, and it also compiled like an ABI file, which is a .json file. If you look at an ABI file, it has a lot of JSON properties, basically, right? It's just a huge JSON files that basically states the functions of your smart contracts and how they are to be called. So basically, it's like an interface for your smart contract. Think of it like an interface. Object-oriented programmers and the rest. Think of it as the ABI is stating all the data types of your blockchain. So if your blockchain, if you have a function that says mint so NFTs, in the ABI you will see mint so NFTs. You will see the parameters for your function. You will see the expected output. So it's basically describing is a blueprint of how to interact with your blockchain. So they are usually exported as JSON files, which are imported in the code base when you are creating a front end, when you are trying to connect to that smart contract, right? These libraries will actually tell you where is the ABI located and to tell you where is the smart contract address. So once the library, like Web3.js, like Ethers.js, once they have the ABI .json, is a JSON file, and the address, they go to the blockchain network address and they use that ABI to call that blockchain, which is why once you set up a blockchain connection, once you set up a library to connect to a blockchain, if you are passing the wrong parameters, even before it gets to the blockchain, it will reject that request because you say, this interface tells me this is the wrong way to call the function. So no, you understand? So basically, that's what ABIs are. I hope I'm. I answered the application binary interface question. Um, so let me open the queue. Mr. Musa Wagode, if you can unmute.
Yes, hello guys. So
Hi.
my question is there a way we can interact like using Web3, that library which communicates with the blockchain, instead of communicating with Solidity, writing for the backend of smart contract? Can we use Node? We can't use Node and maybe Ether, that library which connects with the Web3. Is there a way that we can write method using Solidity?
Oh, I see what you're saying. So if you wanted to connect to a different network, right? Is that what you mean, Musa? Aside from
No. I'm saying, you see, to us to communicate with a blockchain, we use Solidity.
Yes.
And then we use Web3. What do you call Web3 or Ether to connect with it, to connect the front end and the back end. So I'm trying to say, can we, instead of using Solidity to communicate with the blockchain, can we use Node
to communicate directly with the blockchain?
Yes, Node, and then we use this library of maybe Ether or it's called what? That other library.
Web3.js or
Web3.js.
Yes. So you can use a public node to communicate directly to the blockchain via a server. So, for example, an ERC20 server or any like AWS server, if you host a server anywhere, You can get a public node URL, which a lot of providers like Ethereum or different people, they gain a public node quickly and host it, and you can use that URL to connect. Once you call that URL, right, you can connect directly to the network. So you can connect directly to the Ethereum network via a public URL, a public node, right? So if you say you don't use the Web3 JS, I mean, it's fine. Which but the Web3 JS or the Ethers.js are usually for client interaction. So usually they are the things that receive the input from HTML or the user interface, and they know who is making this request, who is initializing this blockchain transaction, right? When I'm doing gas fees, who am I billing? Do you get? Who is signing this node? You need to know who is signing that node in the first place, right? So a lot of times, so that those Ethers.js, those Web3 JS, when you are a dApp developer, you need to use them because people need to trigger the events. You can't, unless you are saying you will now host it somewhere every 24 hours. It takes your money and goes to Ethers or goes to Aave, and do your decentralized exchange by yourself. In which case, you don't need a Web3 JS or Ethers.js. You can just put your private key or public key there. It knows who you are. But but if you're interacting with clients or with users, end users from different parts of the world that you don't know their public or their private keys, if they're initializing a transaction with via your web interface, the way the web interface knows who is making this request usually is from those connectors, those blockchain connectors, which are plugins on their browsers. They connect via those libraries, and that library now, it will now be what will give you the code representation of, okay, yes, this is the address making this call, this is what they want to call. Do you understand? So basically you need it. So the answer for you is yes, you need it. But you can also, the users can call your blockchain directly, which when you use the Web3 JS, you give you use like an API, and they call your smart contract directly from the web browser. Or depending on the architecture of your system, if your system is big and has plenty users, and you have plenty data that you are using the the blockchain to aggregate. For example, I told you like OpenSea, like likes and all of that. So if you're having any auxiliary data to your blockchain data, a way to sync it is using public nodes, that when a user makes the request to the blockchain, the backend will say who made this request, what happened to the blockchain. Oh, this happened to, let's update our DB, right? So that's how that happens. But for any client interaction, you need Web3 JS or Ethers.js. It's, you need to know who is making the interaction, who is paying the gas fees. You need to know if it's a public site, right? Um, those public nodes, those backend nodes are not necessary depending on your application. If it's a simple application, you really don't need them. But for the Web3 JS and the MetaMask.js, or MetaMask.js, the Ethers.js, you need them. So I hope I was able to answer your question, Musa. And it seems to me like question. I'm very deliberate not to get into the code writing part. So what I would do is I would because we have used Remix IDE. So what I'll recommend for us to do is to set up. I know we worked with Emmanuel to set up to read, simple transactions and the rest. But what we need, what you would have to do is before your next class, set up like your node environment or your yarn environment, so that you can use So you can write some front end code, not a lot, bare minimum front end code, and we have already set up Remix IDE. So make sure you go to the website for Remix IDE, get familiar with the interface again, because that's what we are going to use for the practical. So for the practical, we will be creating a smart contract, and then we'll also be using um, a simple user interface to will import Web3.js or Ethers.js, depends on what Samuel decides to use, because Samuel is taking that class. So we import this thing, the libraries, we set it up, and we write our smart contract, we publish it, and then we initialize. We see it in action, basically launch it, host it, local host, and interact with it, and we see how it works in action. So that's for the next class. But this one is for you to understand what ABIs are, what these nodes are, how to set up MetaMask. So another thing, please, if you have not installed MetaMask by now on your system and you're in this boot camp, I don't know why we are here. Install MetaMask or any other blockchain connector to your browser. MetaMask is the most widely used and the easiest since we're using Ethereum. So have these things set up at least by Wednesday so that this introduction we can enter some practicals. Um, so it looks to me like there are no more questions, right? I like that you guys are understanding everything. Oh, this is a very good. This is a very good sign. So, I mean, oh, is someone's hand raised?
There's a question on the chat box. What are the list of what we can install?
Okay, so make sure you have your Node.js set up. MetaMask on your browser. Um, Node.js, MetaMask, the link for Remix IDE. Uh, yeah, and if possible, maybe Ganache. If possible, maybe Ganache. I'll also put the links here to Ganache and the Ganache trophy suits. So for now, I'm not sure if I'm not sure if um I'm not sure if someone is gonna use React or Vanilla JS or anything like that, to be fair. Um, yeah. MetaMask plugin for sure. So the libraries that you will be installing are the library that you'll be playing around with Ethers.js or Web3.js. You guys can look at it, can start looking at the docs. Start from the audience of the for the class. All right. So yeah. Okay, someone says that he will use Vanilla JS. So yeah, so you don't need any React or anything. It's really straightforward. So in that case, I feel like this is the shortest class that I've had, where everybody is ready for practical. for the ones to ask theoretical questions again as well. So success, over to you, I guess, if there are no more questions.
Yeah. Well, I think everyone is pumped up for Wednesday. So I can't wait to see what we all create. Thank you so much, Mamada, for this session. It was indeed an enlightening one. So we await. I'll also post the links on the announcement channel on our server for those that were not able to attend today to also get ready. So everyone, please get ready. It will be practical from Wednesday till the end of the boot camp. So if you've not been so active, then please, this is the best time to get your sleeves on. And best time to get your sleeves on, and let's begin to see where this is heading us to. I know we are heading for the moon, and remember, our criteria remains the same. You need 75% attendance to be able to get certified. We take attendance every session. Feel free to reach us on the general chat. Let's have talk. You have questions, just come. We are here for you. We are not here for ourselves. So if you have any pending questions that you might not remember now, you can ask on the general chat, and we do well to reply you in quick time. Thank you so much. And if we don't have any other question, it's voila from my side. Take care, everyone, and do have a beautiful night rest. Bye-bye.
All right, bye, everyone.
Bye bye.